So you guys have been enjoying yourselves. It's been a long 3 days for me so far. I went to FinagleCon and that was really good, but I'm like full of information and need to decompress at some point. So here's another one. So today I'll be talking about functional error handling in Scala. This talk is more aimed towards people who are coming from, say, like a Java background, or like me. I actually was doing PHP before this. So you come from a traditional, like, more C-like language, and I just want to talk about one of the constructs that you can use to make your code more type safe and more referentially transparent and a bit more reliable. So going back to this, like, let's think about what is error handling. Let's define this, right? And we're going to take the example of Java. What does that mean? It means, usually with error handling, it means throwing exceptions and using try-catch to control the flow of any sort of errors that you might run into. Java does have the concept of checked exceptions, which kind of means that methods will tell you, or in theory, methods will tell you what kind of exceptions it throws. Anyone who has experience in Java knows that this has kind of been it was a good idea, but the implementation and the actual usage of it was a pretty big failure and kind of a nightmare. You can just catch any sort of exception and do whatever you want, and it kind of breaks the whole idea of type safety. Scala doesn't have any sort of checked exceptions. You can do whatever you want inside a function. You can throw an exception, and the compiler will not complain. It will not say anything. So throughout this talk, I'm going to illustrate these functions and this domain using coffee, because I really love coffee. I think it's a very fun hobby for myself. So let's look at this function that I've written here. I wrote it like someone who is like maybe first week of Scala. They're writing something that is a buy coffee function. You give it some money and you expect to get back a coffee object. Within the body of the function, the logic goes, if you let's say you don't give it enough money, which is three whatever, your money being whatever currency you want it to be, let's say dollars, it'll throw an exception, spitting back an error saying, you don't have enough money. I'm sorry about that. Otherwise, return a new coffee. So we defined error handling in the classical sense here. Let's talk about what's functional error handling. Within Scala, or within any sort of functional language with types, it means using error handling types and passing in functions to the context to operate on the values within that type. Why would you want to do this? It helps increase referential transparency. So then what you can do is you just look at the signature of the function, and you can tell that, oh, this function can either be an error, or you get back the type that you're expecting. This has a whole bag of benefits, and I'm just going to hand wave over this, and this is something that is better left to another talk, but it helps increase correctness, and among other things, you can optimize around this. You can cache function return values, and do all sorts of nice little optimizations. And plus, when you're reading it, and you kind of substitute the value in your head, it returns back something that is always consistent. So if you happen to call this function many times, it won't change the actual value. So now that we've defined what the two, like the classical error handling and functional error handling, what I hope you get out of this is an appreciation for what error handling types are, and why you would do it. You get some compiler guarantees. You get referential transparency. You can now just read the types of the functions, and you can understand the general flow of a program. The general gist is that if any of these types can flat map, you can build your business logic around this. You can start to chain functions and and never really leave the context of these error handling types. I feel very passionate about this topic because it's a very practical application of the FP side of Scala. You don't really have to dive so far into, you know, and I'm sure you've attended other talks, but if terms like couneta, like I don't even know what that means, but if terms like that like intimidate you, you kind of can skip over this because this stuff is kind of a little bit further away from the crazy mathy side, which is awesome, but yes, it's the deep end. So I've been talking about error handling types, and the great thing about being further along in the conference is that I don't need to explain what monad is, so I'm just going to breeze through this. But the one-liner I like to give, and this is the vastly oversimplified explanation, is that it's a box that has context. It lets you build computations on top of it, and you can chain things along. The included link is probably my favorite explanation. It's the one that kind of made everything click for me. So now that we've laid down this foundation of functional error handling, how do we go back to our original function of buy coffee and make it better? How can we make it more transparent, more informational? The first thing that and I personally did this myself, and the first thing you would do in this case is use option, use an option type. The option is a type that is either a sum or a none. So it either has a sum value or it returns a type that has nothing. But there's a little minor problem, right? Does now the function tell you what why it possibly failed? No, you'd still have to actually look through the business logic, dig through, and figure out why was this a none. In this case, you'd look and see, and it's the same kind of deal. You'd see the if money is less than 3, then it's a none. We can do better than this. Instead, what you can use is try. It's a construct that comes from the standard library that try represents either your computation was successful or or a failure. In this case, the failure state is signified by an exception being thrown inside the whatever block you have. This is a nice second step because you can enclose in an exception that has a useful message for why things failed. And also, it has the nice benefit of wrapping over code that may be exception laden. So especially if you're working with I don't know Java libraries or code Scala code that someone else wrote that is very exception happy, try is a really good thing to just shove in there. We can, as a third step, we can go even further than that. We can use either out of the Scala standard library. Either it represents a what's called a disjunction or a disjoint union. It's a wrapper of one of two types. In this case, we define it as either a failure reason or you get coffee. It's very similar to how you throw an exception inside the business logic, except the possible outcomes are captured in the type system. By convention, people have adopted that right bias means it's the value they expect. Left indicates an error. However, you cannot flat map over this because the Scala standard library either implementation is not biased. So you'd have to pick a side, and you'd have to enforce this in your own code somehow. There are various solutions to this. One that I can think of off the top of my head is using an implicit class to force a right projection. You don't have to stop at just the Scala standard library. There are most of the functional libraries out there provide a implementation for these. You can use Scala Z disjunction, which is a right bias disjunction. It's pretty much the same thing as in either within the Scala standard library, except you can flat map over it because it is it is right biased. There's also the fantastic little library called Scholastic. I don't know of many users of it, but it's along the same DNA as Scala tests. I think it's actually extracted from there, but it has a really awesome construct for disjoint unions. It's actually left biased, and what this the nice little benefit is that you can write it as infix notation, and the type signature is really it's almost like English because it becomes the good value or the bad value, and that was probably the most clever type hacking that I've seen in a while. But that's one option to use. It also flat maps, except it's left biased. And also out of the new library cats, there's also XOR, which is another right bias disjunction, also pretty much the same exact thing as Scala Z disjunction. The common motif with all these types is that they fail fast, right? What happens when you chain flat mapped computations on top of these? Within the context, if it decides that, let's say with try, if it sees that the previous context was a failure, it will not run your next computation. It just passes it along up until the end of the call chain, and you get back the first failure. In this way, it kind of works as similar to an unhandled exception, where you get an error somewhere early in your call chain, and that's the first thing that it gets returned. Nothing else gets executed. The nice benefit here is with the working with the Scala syntactic sugar of for comprehensions, you can still have this fail-fast behavior. So this is a bit of a larger example here with using a for comprehension with OR. And I chose this one because I just wanted to showcase how awesome this type looks. But I expanded the example to be about purchasing coffee, and underneath are several other steps. First, what you have to do is buy some beans, right? And then and then what you do is after that you brew the coffee. And in this case, I've just abstracted away the logic, but let's say that buy beans has, if you don't give it enough money, you're going to fail and you're not going to have enough money to buy beans. And with brew coffee, let's say you have a really, really crappy grinder or a coffee machine, and a fourth of the time it fails to make a cup of coffee. So you have these functions that kind of represent real life business logic, right? There's not every function in the world will pass. Especially, it's especially applicable to anything where you might be talking to a third party. You can't ever really rely on that third party to be 100% up all the time. So in this case, we're treating the act of making coffee in the same way. So behind the purchase coffee function, I am weaving the two functions together as a for comprehension. First, you buy the beans. You get back some beans, you take that result and you feed it into brew coffee, and what you get yielded back is a OR containing either coffee or the failure reason. Coffee being the good value or the failure reason being the bad. And in this case, you can see that when you run the purchase coffee function, if you don't give it enough money, it will cough up the first error. And even if you happen to give it enough money, the second function may also fail. So it spits back the failure reason. So despite being the easiest, what I think to be the easiest introduction to functional libraries, there are caveats to think about. I think a lot of people like to talk about the benefits of these libraries, but there's also some costs. As with anything in engineering, not everything is there's no such thing as a free win. If there is, if someone's lying to you. So one thing that isn't very talked about is minding your boundaries within libraries. I wouldn't consider it very nice to expose any sort of novice user to what would be maybe like a Scala Z disjunction. I mean, I know for sure for myself, when I first saw it, I was extremely confused because I thought it was some kind of operator that I didn't know about. Also, try Googling for it. You won't. What happens is if you happen to start using this, you bake in a hard dependency to certain libraries, which may or may not have different implications for you, right? So let's say that you have a team of mostly Java developers who are coming onto Scala, and you've got the one hardcore Haskell guy who wants to bring in Scala Z and use all these crazy constructs that the rest of your team will not understand. That's something to really think about. That's of course this is more of like a management thing, but don't think of it as a free win, but think of it as a possible good first step. And this is something, my third point in this slide is something that I have been meaning to investigate for myself and would really want to see the actual hard numbers is that performance numbers. Like, do you take a hit by boxing values into these types? Do you see what kind of things you give up to get more compiler safety? As always, make these decisions on your own or do your due diligence. And I think that the benefits obviously outweigh whatever costs, but don't go into it blindly. So a lot of this talk was actually inspired by specifically this chapter in the fantastic Functional and Programming book. I think the first half of this whole slide deck was basically based off of the chapter 4. I really recommend reading this book if you're interested in what it means to really apply FP in Scala. It does probably the best job in taking some just a raw idea and actually implementing it and taking it all the way across the finish line. So that was just basically a short introduction to what functional error handling is like. Before anyone asks, there is another side that's functional error accumulation, and that's what's known as validation. Yes, and that is a whole other half of this talk. I've only got 20 minutes, but if you're interested about that, there is more, and I actually wrote a little blog post about it as well. I did not include a link. But any questions? Yes?
The slides, how can we get the slides? Are they at GitHub or?
I have them on slides.com right now. That's right. I was asked about the slides. I have them hosted on slides.com right now. I'll be emailing a PDF copy to the conference organizers. I think they'll be posting the slides and the videos somewhere. Yes?
So you put much more emphasis on these introduction types instead of the standard libraries try, which you mentioned only very briefly. And I was wondering if you could say a little bit about why.
Right, so I was asked why I put more emphasis on disjunctions rather than standard library constructs like try. And actually try is the perfect example of what I think is more of like a transitional type. And I didn't mention this in my slides, but I think what happens with try is that if you keep it around for a while, people will continue to use exceptions as part of their error handling toolbox. So I think it's more of a good way to insulate yourself from exceptions, but the longer you keep it around, the more people will keep using exceptions. And that's kind of like one of the points that I wanted to make was that, try and eliminate exceptions. Don't rely on it, but encode your exceptions into the type system. Use some kind of ADT that can represent errors. Yes, in the back. I'm sorry, what was that? So the question was, are exceptions okay sometimes? So let's say if you're thinking purely, then no, it's not okay. But we live in a gray world, so it will, especially if you're interacting with, say, like Java libraries or JDBC or whatever, exceptions will happen. The point that I was trying to make was that you want to insulate yourself from exceptions wherever you can. So in the case of some kind of code that throws exceptions, try and use try to wrap around that. Any last questions? Thank you very much.